Hello students, welcome back to CLARIconcepts, Unleashing Conceptual Learnings. Today in this lecture, we will be solving various numerical examples on hydrostatic force on a plane surface. Okay, so those of you who have not yet viewed my previous lecture where I taught about hydrostatic forces and its evaluation and the location of center of pressure, first kindly go and look at that lectures and then come back to this lecture. Okay, let us continue. So I'll just brief you about the formulation. So let's say if I have a plate and the plate is submerged, and if you are supposed to find out the force of hydrostatic force on the plane surface, the formulation is such that the Fr is equals to Pc into area, which means that if I have a plane surface submerged in the surface of fluid, if I want to know what is the total hydrostatic force because of the fluid pressure, I need to multiply the pressure existing at the centroid point of this plane with the area of this plane. So that means firstly your task is to locate the centroid. Once centroid is located, find out the fluid pressure at that particular point and then multiply that pressure with the area to get the value of the force. Once force is known to you, then you need to calculate, if you would also like to know that at which particular point on a surface this hydrostatic force is acting, that means center of pressure, then what you need to do is you need to find out the value of yp, where yp is the distance measured from this axis, right? We have understood this. So this is yp from here to here, center of pressure. And that is nothing but yc, which is the location of y coordinate of centroid point of the plane surface C, plus ixx, which is the area moment of inertia of this planar surface from the centroid point through xx axis. Again I am repeating the things. See, ixxc is the area moment of inertia of this particular plane surface through the centroid point. Let's centroid point is somewhere over here, and that too from the xx axis, that means this axis, the axis of my pen perpendicular to the board. From top when you see it is something like this, right? Yc again you know, Po is the pressure of the atmosphere, rho density of the fluid, G 9.81 meter per second square, sin theta is the inclination angle, and A is the total area of this plane surface. Clear? Let us solve the numericals now. Say for example I have the first case. A heavy car plunges into a lake during an accident and land at the bottom of the lake on its wheel as shown in figure. So there is a heavy car which has ended into an accident, which has met an accident, and the car has went into the lake. Okay. The door is 1.2 meter high and 1 meter wide. So the door of the car is 1 meter wide as you see and 1.2 meter in height. And the top edge of the door is 8 meter below the free surface of water. That means the top edge of the door is 8 meters below the free surface of water. Determine the hydrostatic force on the door and the location of the pressure and the location of the pressure center. So firstly we will talk about the hydrostatic force Fr. We know that Fr is equals to pressure at the centroid into area of the door. Pressure of the centroid into area of the door. Now firstly locate the centroid. See, this is 1.2 meter in height. So centroid will be somewhere over here, C, which is at the distance of how much meters? So 1.2 is total, this is 0.6. So total distance of centroid point from the free surface is how much? This is 8 plus 0.6, so this will be 8.6 meters. This is your HC for example, for instance. Height of, the depth of centroid of this particular door. So once you got this, you can say PC equals to P0 plus rho GHC into, what is the area? Area is this 1 into 1.2. 1 meter wide, 1.2 meter height. Simple. Now P0 you can consider as 0 Pascal gauge when you talk about atmospheric pressure. And rho is density of water, which is 1000. G is 9.81. HC is 8.6. Into area is 1 into 1.2. Simply do the calculations and get the answer. I will get the force as 101,239.2 newtons. This is the resultant force acting on the door of the car at this particular depth, isn't it? Now question is, what is the location of Yp? So let us suppose Yp is somewhere, because the car is exactly in a vertical direction. So I should say that theta is almost, you can say 90 degree, and Yp is somewhere like this, right? So Yp is basically the distance. Now what you will do? you will try to look at the what do you call the formula, which is yp is equals to yc plus ixx of c divided by yc plus p0 rho g sin theta into area A. Alright, now you can just simply see P0 you can consider to be 0 as atmospheric pressure. So this formula will boil down to Yp is equals to Yc plus Ixx from a centroid point divided by Yc into A. Now just find out these values. Firstly, what is Yc? Yc, we have calculated the distance, vertical distance directly, which was hc, 1.2 meter is height, so you can say c is somewhere over here. So this is 0.6 and this is 8. So total distance of yp, or you can say hc, both of them are one and the same. So yc or hc, they are both 8.6 meters. So yc is 8.6 meter. Now what is ixx? See, this is the door. Ixx means central point is somewhere over here. Your x-axis is like this. So you need to calculate this area moment of inertia of this area from this axis. So you see, this will be what? This is 1.2. This is 1 meter. So you need to do BD cube by 12. Cube will be of those with, see, if I want Ixx, I hope you are aware that for x-axis, the cube you will take will be of the perpendicular line in order to remember this, right? So Ixx from a C will be equals to, I hope you are aware that this is 1.2 meter of length, this is 1 meter of length, right? So you will, if you want I from this axis, which is the perpendicular length, this length. So you have to take cube of this length. So 1 into 1.2 cube divided by 12. BD cube by 12 is the area moment of inertia for the rectangular section, right? So this Ixx from C will be 1.2 cube divided by 12, which is 0.144 meter raised to 4 is the unit. Alright, now put the values. What is area? Area is 1 into 1.2, that is 1.2 meters square. All the values are available with you. Yp will be equals to 8.6 plus 0.144 divided by 8.6 into 1.2. You will get Yp as 8.6139 meters, just below Yc. Let me check the answer. 8.614, perfect. 101239 is the around value of force. Let me check. 101239. Okay, perfect. This is the answer. So I hope you understood this. Answer 2 about the location of center of pressure, and this is answer 1 about the value of the hydrostatic force. Yes, so you can solve these examples in a similar way. Let us take one more example to give you more clarity on this. A rectangular plane surface 3 meter wide and 4 meter deep lies in a water in such a way that its plane makes an angle of 30 degree with the free surface of water. So for example, what you have is a plate from a free surface, okay, at an angle of 30 degrees, and it is said that the plate itself is 3 meter wide and 4 meter deep. So 3 meter wide and 4 meter deep, and the upper edge, there will be something like this. Determine total pressure of the force and position of center of pressure when the upper edge is 2 meter below the free surface of water, which means this is the plate and this is the upper edge. So upper edge, if you see, upper edge is 2 meter below the free surface of water. So somewhere like this, right? I'll just put 2, yeah, here, 2 meter below, right? Now what they have asked you to find out the FR value, and they have asked you to find the value of Yp. Can you do it? Very simple. Let's go ahead. Firstly, what is FR? FR is equals to pressure at centered into area. PC is P0 plus rho GHC into area. P0 can be considered as 0 Pascal. So rho GHC into area. What is HC? Rho will be known to you, 1000. G is 9.81. What is HC? Centroid point. So HC is the distance, this one. Let's say A, B and C. Now, see, this is 4 meter, total is 4 meter, right? So can I say this distance is basically 2 meters? Yes, if this is 2 meter, what can I say is, firstly I will calculate this distance. If this is 2 meter, angle is 30 degree, what will be this distance? I can say, let us say, suppose the distance is some distance A. Can I say this 2 sine 30 is equals to opposite by absolute, I mean hypotenuse, that is A. So A will be equals to 2 by sine 30, which is equals to 2 divided by sine 30, which is equals to 4 meter. So this A which has been found is 4 meters. Now this is 4 meter, this is 2, total is 6 meter. So 6 meter cos 30 is this, and HC will be 6 meter sine 30. So we will use 6 into sine 30, and this is rho g HC. What is the area? Area of this plate, 4 into 3. 4 into 3. Do the calculation, you got the answer. Into 6 into sine 30 into 12. The answer I am getting is 353,160 Newton. This is the resultant force acting on the surface. Let me check the answer. 353,160. Perfect. Now the question is, find out the value of YP, isn't it? Now what is YP? Let us check. YP is equals to YC plus IXX from a centroid point divided by YC into A. I have just neglected the pressure of atmospheric P0. Okay, P0 is directly neglected from the formula. Okay, so I have used the final form. Now, most important is finding out the IXX. You look at this. I have this area. This is the plane surface. Okay, I have centroid point somewhere over here, and I want to find out the I from this axis, from the pen's axis. So if you look at it from top, you have to do cube of this, because you have to do cube of which length? Perpendicular line to the axis, right? So this is B and this is D. So B, D cube by 12. So what is D? This is 4 meter. So IXX will be 3 into 4 cube divided by 12. Remember always that you have to do cube of the length perpendicular to the axis from where you need to find the I. If you are not aware about that, kindly go through some videos of this particular topic. So I will be 3 into 4 cube divided by 12. It is 16 meter raised to 4. Now put the values. YP equals, what is YC? YC is this distance. We have calculated this to be 4 meters and this to be 2 meters is already given to you. This is 4, so this is half, that is 2. 2 plus 4, 6. So YC is 6 plus IXX is 16. YC is 6. Area is 4 into 3. Area of the plate. Now find out the answer. 16 divided by 6 divided by 12. And then plus 6. This is YP is 6.22 meters. Answer 2. I hope you got this answer. Let me check. 6.22, perfect. It's perfectly fine. Right? Okay. So now let us check another example. A tank of oil has a right triangular panel near the bottom as shown in figure. Find the hydrostatic force acting on the panel. Now you have been given a figure. Now see, this is the oil tank, and the oil tank has a bottom of the right triangular panel. That means if you look at it from top side, it is looking like this, something like this, a triangular one, right? And the dimensions are given to you. They are asking you to find out the hydrostatic force. Simple. What is force? I know Fr equals to pressure at the centroid point of the panel multiplied by area. Now firstly you will find both this value, PC and A. Now firstly you locate the centroid point. Where is the centroid point? If you see, centroid point is somewhere over here, say for example. Okay, so if this distance total is 12, so 8 and 4. So always centroid point is located 1/3 of the total distance. So 1/3 of the 12 is 4 meter. Therefore this is center. Now if you look at it this way, this distance is 4 meter. Okay. Now when this is 4, that means this is 5. So pressure at this point, what is it? P0 plus rho g, 5 plus 4, 9. Isn't it? So PC will be equals to P0 plus rho of oil G and HC. You can take P0 as 0. So rho of oil is 800 given to you into 9.81. HC is what? 5 plus 4, 9. You calculate this into 9.81 into 9. This is 70632 Pascal. Once you know pressure at C, now find out the area, triangular area. See what is the area of this triangle? 1/2 this into this. So 1/2 total is 12 into this total is 6. So this will become, this is 3 and 36 meters square. Simply put it over here to find the answer. See, it's very easy. The only point is how clearly you understand the concepts. 70632 into 36. Once you know the concept, you can easily solve any numerical. But for that, you need to have the concentration and that patience to understand the concepts well. 2542752 newtons. This is the answer. So let me check. 2542752. 25427. Perfect. Answer. Clear? So I hope you are aware about how to solve these numericals on hydrostatic forces. Thank you so much. See you in the next class where we will talk about the hydrostatic force on the curved surfaces. Thank you.